This brings us to our second exercise, where we will use at-risk to set up some consequence distributions. The instructions tell us to define PERT distributions for the breach and non-breach life loss at each peak stage listed. We are told to assume perfect correlation between breach and non-breach life loss, and to complete the incremental table at the bottom of the sheet. To start, we will define a PERT distribution in cell F14. The function is risk PERT as shown in the formula bar. The first input is the minimum value, the second is the most likely value, and the third and final input is the maximum value. The formula will be the same for all the other stages, so we can drag the formula down to complete the breach life loss table. Next, we will do the same thing for the non-breach life loss. The function is risk PERT, and the inputs, in order, are the minimum, the most likely, and the maximum life loss values. Drag that formula down, and we are ready to build our correlation matrix. To correlate the breach and non-breach life loss, we will highlight the yellow cells in column F that hold the breach life loss distributions, and then, while pressing the Control key, highlight the non-breach life loss distributions in column L. Click on the correlation button from the tool ribbon. The dialog box will ask you to specify the inputs. Because you have already highlighted them, you can just hit Enter. In the next window, the correlation matrix will be displayed. You can edit it here if you want, but I find it to be quicker and easier to edit the table after it's added to the spreadsheet, so I will just click OK. A dialog box will ask you where you would like to place the correlation matrix. Select the yellow box under Correlation Matrix, then click OK. Here is the correlation matrix. For perfect correlation, all the zeros will need to be ones. We can override all the zeros one at a time by hand, or the easiest and most efficient thing to do is to highlight all the values in the table and hit Control F to pull up the Find command. Then you can find all the zeros and replace them with ones. Once complete, the correlation matrix should look like this, with all table inputs now set to 1. Now we are ready to scroll down to the bottom to fill out the incremental life loss table. The incremental life loss is equal to the breach life loss minus the non-breach life loss. This equation is what we will set up in the output cells. For a stage of 470.9, input the breach life loss from cell F14 and subtract the non-breach life loss from cell L14. Once we have that equation set, we need to mark the cell as an output so that at-risk knows to store data for the cell once we run the simulation. Select cell C45, the cell we just populated, and then click Output from the at-risk tool ribbon. A dialog box will prompt you to name the output. You can name it if you like, or you can just click OK to leave it unnamed. The formula now starts with risk output and a set of parentheses, plus the formula for incremental life loss we already input. If you name the output cell, the name in quotes would show up between the parentheses. To call the percentiles, the formula is risk percentile. The first input is the output cell, and the second input is the percentile in either decimal form or percentage form. For the fifth percentile, type in risk percentile, set the first input as cell C45, followed by 0.05 or 5%. Repeat for the 50th percentile and the 95th percentile, where the inputs will be 0.5 or 50% and 0.95 or 95%. Because we have not run the simulation yet, the value at-risk returns will be the same as that shown in the output cell. They will change after we run the simulation. Next, we enter the formula for the mean. The function is risk mean, and the only input is the output cell C45. The last column asks for the results from the 20th iteration. We will use risk data to call the value. The formula is risk data followed by the output cell, the iteration number, which is 20, and then the simulation number, which is 1. With the formulas all set, we can drag them down to populate the rest of the table. We are now ready to check our settings and run the simulation. The settings are the way we want them, with the iteration set to 10,000 and the sampling type set to Latin hypercube. Click OK to close the dialog box. Then click Simulate to run the analysis. It will take a few seconds, but when it is finished, you'll notice the percentile values and the means all changed. Your results should be very close to what you see on the screen, and they should not vary by more than a decimal point if everything was done correctly. Next, let's check our simulation data to make sure we called the 20th iteration properly. Click on Explore, then Data, which is down towards the bottom under Simulation Details. Scroll down through the data table until you get to the 20th iteration, and you'll see the data matches what we have in our table. You are not asked to do it, but to save the simulation results, click the Save icon in Excel, just like you normally would, and the following dialog box will pop up. The data from this simulation is small enough to save directly in the workbook, but I find that it is better practice to save the data as an external file by choosing the middle selection. So long as the simulation file is saved in the same folder with the spreadsheet, At Risk will ask you if you want to open the simulation file the next time you open the spreadsheet. If you are not asked about opening the simulation file, you can click on Utilities and choose Open Simulation File to pull in the data. This is also where you would go to clear any simulation data should you want to remove it from a file.